Okay, hello. We've been working on rational functions. The problem at hand is the following: f of x. All right, f of x equals 2x minus 1 over x. We have some things we're looking for. The first thing is, what is the x-intercept? Okay, the x-intercept, that's going to be a certain number when y is equal to 0. So why don't we just plug in 0 for y? Remember that f of x is also your y. So we're going to say 0 equals 2x minus 1 over x. Let's see if we can figure out what would make this statement true. What value for x would make this statement true? Well, I'm really concerned about the numerator, just the numerator to be 0, because the denominator could be anything other than 0, but we'll get to that. So the numerator should be 0. So let's just say 0 equals 2x minus 1. Let's do some simple algebra to solve for x. Let's add 1 to both sides. So that way these cancel. We've got 2x on the right side of the equation here. Equals 1. I need to isolate x further. I've got 2x. I don't want that. I have 2 times x. So let's do the opposite of times. Let's do divided by 2. These will cancel. X equals 1/2. X equals 1/2. That's going to be my x-intercept. Let's just keep track of what we're solving for over here. X-intercept was x equals 1/2. All right. So, we're looking for the y-intercept now. Y-intercept. What is y when x is 0? Okay. Well, if I go back to my original equation, I plug in a 0 for x, that's going to put a 0 on the denominator, and we cannot do that in math. We cannot have a 0 on the denominator. So I already know there's a problem there. I'm going to say that there's no y-intercept for now. We'll look further into this. Y-intercept, I'm going to say none. All right, that ties in nicely with our vertical asymptote. So vertical asymptote, that goes up and down. Um, if we know that y, if there's no y-intercept, we also know that that's our vertical asymptote. I'll show you a graph at the end. Let's do horizontal asymptote. We've got this chart, this little anchor chart we've been using to help remind us of how to find the horizontal asymptote. This is just a little rule of thumb to go by. The important part here is this. So we got 3 different options. The numerator could be less. This is the degree of the numerator. So that means x with its exponent, that's your degree. If the degree of the numerator is less than the degree of the denominator, we're going to use the first option. If they are equal, that's what the n and d means, numerator and denominator. If they're equal, we're going to use the middle option. If the degree of the numerator is greater, we'll use the bottom option. So for this problem, let's go back to our problem. The degree, our highest x value is a 1. If there's nothing written there, you know it's a 1. And then the x on the bottom, that's just going to be a 1. So I've got a degree of 1 on the top and the bottom. So that means they're equal. So I'm going to use this middle option here where it says the horizontal asymptote is y equals 2/3. Okay, well, that's just this specific example. How did they get that? Well, we're going to use the leading coefficient on the numerator over the leading coefficient of the denominator. That's how they got the 2 and the 3, 2 over 3. So for our problem, let's do the leading coefficients. We've got a 2 and a 1. There's nothing written here, so I know it's a 1. 2 over 1. So that means my horizontal asymptote is going to be, what did I just do? 2 over 1. So y equals 2 over 1, which is also just 2, the whole number 2. And we'll look at the domain very last. So now we're going to, let's screen share. All right, let's type in our problem. Here's how you would type it into Desmos. Let's get the numerator. You don't even have to type in y equals, that's already there. So it's parentheses, let's do 2x minus 1. Parentheses, 2x minus 1, parentheses. That's our numerator. We had to put parentheses to make it all our numerator. Divided by x. Okay, this is what our rational function looks like. We can check our answers. So we got an x-intercept of 1/2. So at x equals 1/2. Oh, look at that. I can see that perfectly. This is 1, if this is 2. So this is 1/2. So that is correct. Let's see if we can even graph that. Let's type in x equals 1/2. Perfect. Look. It's right where they meet. All right, so x equals 1/2. That's our x-intercept. We've also got a horizontal asymptote at y equals 2. So let's see if that matches up perfectly. It does, because the asymptote, it goes on forever and our function is not touching it. Look at that, it goes on forever. It's going to get closer and closer and closer and it's not going to touch it. Let's talk about the vertical asymptote. So it's going to go up and down, and it's going to be the line that this function never touches. So it does look like, let's see. Oh, yes. So what can x not be? X cannot be 0. Because we cannot have a 0 in the denominator. So let's add x equals 0. Oh. X equals 0. There it is. That's our vertical asymptote. Domain is our last question. So domain is everything that x is. Does it go on forever in terms of negative infinity? Sure does. It's going to go on forever. So I've got negative infinity until 0 exclusive. And we're going to unite that with 0. Wait. No, that's not 0. This was our asymptote. Wait. Is it 0? It is 0. Okay, so we're going to do negative infinity, comma, 0 in parentheses, united with 0 exclusive all the way to positive infinity. That's our domain. So x can be everything but 0. Another way to say that would be x and then do an equal sign with a slash through it, 0.